Once again, welcome to our today's class, and we will want to actually focus more on a topic in chemistry, and the topic reads the structure, okay, the structure of an atom, the structure of an atom, and the periodic table. So I'm going to introduce those concepts that fall under that topic one by one, and you shall be able to actually end up having a better understanding of what the topic normally communicates to us. So to begin our discussion, I'll first begin by looking at some terms which are very important in as far as this topic is concerned. And some of these terms that we are going to even first define are, for example, the first one is an element. We'll first need to understand what an element is. And everybody knows it must first be a pure substance. An element is something which is pure. So it's a pure substance which can not be split into, simpler substances by chemical means. So it must first be a substance which is pure. So it is a pure substance. And the good thing with this pure substance is that you cannot split it. So it cannot be split. A pure substance that cannot be split. So you cannot split it. You cannot separate it into smaller parts. So it's a pure substance, number one, and you can't split it into simpler substances, basically by chemical means. Let me give you a practical example. If I pick this to be an element, this element must first be a pure substance. Okay? Then it is difficult for me to split this thing into simpler substances by any chemical means. So that is to tell you that a chemical reaction cannot split this element into simpler substances. So it is just impossible for us to split this element into simpler substances by a chemical reaction. Not physical means, but a chemical reaction. Of course, physical means like heating, using a hammer, can split an element. But you are saying a chemical reaction cannot split this pure substance into simpler substances by a chemical means. You get the point? So that's the definition of an element. Something else to look at is an atom. An atom, we can define it as the smallest particle of an element. Smallest particle of an element that can take part in a chemical reaction. Nice. The smallest particle found where? In an element, and can take part in a chemical reaction. Let me give you a good example. I can say that this is my element. And inside the element, we can have what you call an atom. Look at that. I guess you can be able to see that dot. So this becomes now the atom, this one. So this one becomes the atom, and it can get defined as the smallest particle of this element. And this smallest particle of this element can take part in a chemical reaction. So any small particle that you can find in an element, inside an element, and that smallest particle can find itself taking part in a chemical reaction, can qualify to be called an atom. So any small particle you find in an element that can take part in a reaction is called an atom. And for your information, the title of what we are discussing is structure of an atom. So we want to look at the structure of an atom. That is to say, we are going to pick the smallest particle from this element and come and look at the way it looks like. You get the point? So we shall actually go to something called the structure of an atom. Structure of an atom. Basically, this is a small particle, but that particle can get enlarged. Look at that. It can get enlarged, it can get magnified. And after an enlargement, this can qualify to be now the atom. The atom has the following parts. Number one, it has what you call the nucleus. Okay? The nucleus. The nucleus is this. This is the nucleus. This is the nucleus. And you always define this as the central region. Central region in an atom, or a region found at the center. The central region of an atom, or the central region in an atom, or the region found at the center is what you call the nucleus. And this central region found in an atom, or the central region in an atom, is occupied by protons and neutrons. I guess I'm going to actually help you understand the meaning of protons and neutrons. But first, know this central region in this atom is what you call the nucleus. So the central region in an atom occupied by protons. So that means protons, look at that, protons and neutrons are found in the nucleus. So that is P for protons and N for neutrons. So protons and neutrons are found in the nucleus. And the nucleus is the central region of an atom. Look at that. The word central comes from the word center. So this central region in this atom is what you call the nucleus. And this central region is occupied by two particles, protons and neutrons. P for protons and N for neutrons. Now, apart from this atom having the nucleus as the central region, it also has what you call, number two, subatomic particles. So number one, nucleus. Number two, subatomic particles. Subatomic particles. I guess, look at this, subatomic. So that means the smaller particles found in an atom are called subatomic particles. Substitute. You know, you have what you call the main players that begin the game and the substitutes. Always being ready for them to actually get introduced into the game when a major player maybe gets an injury or gets tired. So inside an atom, we have particles. Those particles are called subatomic particles. Particles inside an atom are called subatomic particles. And those particles are three. Number one, you have what you call protons. Okay. Number two, you have what you call neutrons. And number three, you have what you call electrons. So that is to tell you that in an atom, there are three main types of particles. We have protons and neutrons found in the nucleus. Then we have electrons found outside the nucleus. Electrons found outside the nucleus. Electrons found outside the nucleus. Great. So three particles, protons, neutrons, and electrons. Protons and neutrons inside the nucleus. Electrons outside the nucleus. Correct. Now, apart from that, we want to see what are some of the properties of this particle that are found inside this atom. What are protons, what are neutrons, and what are electrons? Do they have anything that they can actually be able to get to a point of communicating to us so that you can be able to have a better understanding of what they are? One, you need to understand that protons are positively charged. Look at that. They carry a positive charge. And for your information, electrons are negatively charged. So electrons carry a negative charge. So if I say P, you just say positive. P positive. That is to say, protons are positive, or protons are positively charged. Then electrons negatively charged. They carry a negative charge. Then we can say neutrons. Neutrons are neutral. That is to say, they don't carry any charge. So you can just represent this with a 0. So they don't carry any charge, so they are neutral. Neutral. These ones are negative. So protons, positively charged. They are positive. Electrons, negative, negatively charged. Then neutrons, neutral. They have no charge, so they have a 0 as the charge they're actually carrying. And literally, you really need to understand this, that these particles are found in different positions. We've said one, that protons and neutrons are found inside the nucleus, but electrons are found outside. Electrons are found outside. So you cannot find electrons inside the nucleus. They are found outside. They are found outside. Okay, if I come here, I want to pick an element like X. I've been given an element like X, and I've been told this element is number 4. That's a good example to use. That means we need to give the number of protons, the number of electrons, okay, and the number of neutrons. You have been given element X. I've hidden the identity for the sake of just making it clear for you to understand. And this element X is position 4 in the arrangement of elements in a structure called, or in a grid called, the periodic table. So element X is position 4. Once someone tells you that this element is position 4, what comes into your mind? Just know this, that this element must be having 4 protons, okay? It must be having 4 electrons, and it must be having 4 neutrons, for that matter. But sometimes it will vary. You'll find an element having 4 protons, 4 electrons, and maybe 5 neutrons. It all depends on the type of element you're actually dealing with. But just know this, in most cases, if an element is position 4 in the grid, okay, or the periodic table, then that means it must be having 4 protons, it must be having 4 electrons, it must be having 4 neutrons. Correct. So it has 4 positives, because protons are positively charged. It has 4 negatives. And lastly, the neutrons have no charge. Look at that. So 4 positives, 4 protons, okay? Then we have 4 negatives, right? Then we have no charge. That means the 4 neutrons have no charge, but the 4 electrons have a negative charge. The 4 protons have a positive charge. That is just to make you understand better. Now, something very important for you to note, is this, is that in an atom, protons, neutrons, and electrons carry different masses. That means if I find one proton, I find one neutron, and I find one electron, what are their estimated masses? You get the point? We call them relative masses. So relative mass. That is to tell you that one proton should weigh a particular mass, one neutron should weigh a particular mass, and one electron should weigh a particular mass. That is called relative mass. One proton will literally have one atomic mass unit, one neutron will have one atomic mass unit, and one electron is able to weigh 1 over 1840. 1 over 1840 is equivalent to, let me check, 1 divided by 1840. Yes, you can be able to see from there, 1840. That is the same as, let me just readjust the settings of the calculator so that I can be able to know Correct. So 1 divided by 1840 gives you 0.000543. So 3 zeros and 54. So I can rewrite 0.12354. So those are just the relative masses of those three particles found in an atom. So one proton can relatively weigh 1 atomic mass unit, 1 neutron, 1 atomic mass unit, 1 electron, 1 over 1840, or 0.00054. Correct. And of course, if you have any question, you can be able to ask. And if we leave that part, we can go to something else. And whatever we want to look at is also very crucial and very important to us. And that is atomic number first. And you'll wonder what is atomic number for information. Atomic number is the number of protons. Number of protons. So the number of protons in an element will give you what you call the atomic number. Or the number of protons in an atom will give you what you call the atomic number. Assuming I have an element like, let me say, sodium. It is a very common element that everybody knows or must have come across. Sodium is number 11 in the periodic table. So that means atomic number of sodium is 11 for information. Or you can also say number of protons is 11. So in short, atomic number is the same as the number of protons. So if an element is number 11, that means the atomic number is 11. That is also to tell you that the number of protons is 11. So it is just simple. Atomic number, number of protons. So if an element like sodium is number 11, that means it has how many protons? 11 protons. So what is its atomic number? 11. It's as simple as that. So the atomic number refers to the number of protons. So if an element is number 11, the number of protons is 11, and the atomic number of the same element is 11. Okay, something else to note. We have something called mass number. Mass number. Don't worry, number is just NO in short form for you to actually understand. Mass number refers to the sum of protons and electrons. The sum of protons and electrons. Sorry for that. Sum of protons and neutrons. Sum of protons and neutrons. So the sum of protons and neutrons. We cannot use electrons because protons and electrons have the same number. So we shall actually be able to bring about a contradiction. So we can just better say sum of protons and neutrons. That seems a bit better for us to actually apply. Because it's not in most cases that you'll find the number of protons be equal to the number of neutrons. But in most cases, in fact, equally almost every case will have the number of protons be equal to the number of electrons. So we better say sum of protons and neutrons. Remember, students, mass number is also referred to as nucleon number. Nucleon number. So if someone says mass number, you can also even as well say nucleon number. What do they mean, these two terms, which are the same? They are synonyms. They mean the sum of protons and neutrons in an atom. In an atom. Now, let me give this example. I have an element like magnesium. And of course, everybody knows magnesium is number 12. So if magnesium is number 12, then that means it must have how many protons? It has 12 protons. Then it will obviously have 12 electrons, and it will end up having 12 neutrons because it has 12 neutrons. So the number is the same for protons, neutrons, and electrons. So I want to get its mass number. I want to get its mass number or nucleon number. How do I get mass number or nucleon number? I take protons and neutrons, then sum them together. You see, I sum them up to get the mass number or nucleon number. So I'll say Mn. Mn stands for mass number. As per me, in terms of its abbreviation, mass number is equivalent to protons plus neutrons. How many protons are here? 12. Correct. How many neutrons? 12. So we can sum these two to get the mass number or nucleon number. So talk about mass number or nucleon number. So mass number or nucleon number is equivalent to the protons plus the neutrons. Our protons are 12, our neutrons are 12. The sum becomes 24. So this becomes the mass number or nucleon number. Nice. Let's proceed. So, why do you also call it nucleon number? Look at the word nucleon from the word nucleus. We are taking protons and neutrons. And I told you in my previous discussion that protons and neutrons are found in the nucleus. So they get added together. If they get added together, because they are found in the nucleus, they can give us what you call the nucleon number. So protons and neutrons are found in the nucleus. When they get summed up, they give us what you call nucleon number. So the sum of protons and neutrons can give us mass number or also nucleon number. Why nucleon number? Because whatever we are adding together is found in the nucleus. So we can also call it nucleon number. Okay, so you may want to represent both mass number and atomic number on an element. You want to represent this atomic number and this mass number on an element. Now what do? I have told you, let's use this example of magnesium. I've told you that number of protons is the same as atomic number. Let's forget about potassium. So atomic number is the same as number of protons. So how many protons are here? 12. Mass number or nucleon number is protons plus neutrons. So protons 12, neutrons 12. Mass number 24. So we want to represent both this atomic number and this mass number on this element called magnesium. Chemically, magnesium is capital M, small g. That's the chemical formula. So if I go somewhere and then just say capital M, small g, any scientist will just know that that is the formula of magnesium. Someone is referring to magnesium. So magnesium is capital M, small g. How do I represent this atomic number or number of protons and this mass number on this element? Mass number is written as the superscript, super on the top of the element, superscript. Then atomic number is written as a subscript. But don't circle them, I'm just circling for the sake of giving more emphasis or trying to show what you're trying to do. So the chemical formula of magnesium, capital M, small g. The mass number written as a superscript on top of the element. The atomic number written as a subscript at the bottom. So superscript, mass number, subscript, atomic number. So write the mass number at the top, atomic number at the bottom. On the left, of course, maybe, let me just use that, on the left hand side of that chemical formula. Yeah. So that will give you what you call mass number and atomic number. Mass number and atomic number. Unless you have a question you can ask, but that's easier for you to understand. And I guess maybe if you have an element like, which example can we also give? Let's give an example of lithium so that you can just understand. So lithium is number 3 in the periodic table in terms of the arrangement of the elements. So we need to get its number of protons. And I've told you protons refers to also atomic number. So obviously it will be 3. Okay, electrons, how many are they? This element has 3 electrons. And lastly, we want to see the number of neutrons. Neutrons are 4. You see, that's why I told you it's not possible for you to just find a situation where all the elements have the same number of protons and the same number of neutrons. In some elements, the number of protons must be different from the number of neutrons. But in most cases, almost every case, you'll find the number of protons and the number of electrons being the same. So if it's 3, it is 3. Protons and electrons are the same. If it is 12 protons, it is also 12 electrons. Look at that. So it must be the same. 10 protons, 10 electrons. 11 protons, 11 electrons. It must be the same. So here, the protons and the electrons are the same, obeying the same rule. Okay? but the number of neutrons has actually differed here. Protons or atomic number 3, but neutrons 4. So let's first get mass number. So you shall say mass number. Of course, you know how to get mass number. You'll say protons plus neutrons. Protons are how many? 3. At the top here, protons are 3. Then neutrons 4. So you say 3 plus 4. What do you get? 7. So the mass number is 7. So we want to actually represent the atomic number or the number of protons and the mass number on this element called lithium. So chemically, how do we write lithium? We write lithium as capital L small I, that is lithium. Our mass number is what? 7. I've told you mass number must be written as superscript. But atomic number or number of protons must be written as subscript. So mass number 7, atomic number 3. Mass number written as a superscript, atomic number written as a subscript at the bottom of the chemical formula of that element on the left hand side. Yeah, so that is all about trying to write the atomic number and the mass number of an element on the chemical formula of that element. Something else that I want us to focus on is the electron arrangement. How do we arrange electrons in an element or in an atom of an element? I don't want to repeat this. We've done this and I've actually explained this in detail. And I've told you that if this is an atom, at the center we shall have protons and neutrons. And now outside we shall have electrons. So we want to see how these electrons get arranged outside the nucleus. That's what we mean by electron arrangement. Electron arrangement. Electron arrangement. Correct. And for your information, I may say electron arrangement, or you can also refer to it as electron configuration. Electron configuration. So we want to see how the electrons are arranged or how the electrons are configured outside the nucleus. You see, outside the nucleus. Oh my good student. These electrons are not found in the nucleus. They are found outside the nucleus. Where exactly are they found? How do you call this region? This region is referred to as a region of energy levels. So energy levels. So energy levels. So electrons occupy energy levels. Oh, what about protons and neutrons? They are found in the nucleus. What about electrons? They occupy energy levels. So where electrons are found, we'll refer to these regions as energy levels. So electrons occupy energy levels. What are the energy levels? Regions around the nucleus. Regions around the nucleus. So look at this. Regions around the nucleus. So these regions are found around the nucleus. They are called energy levels. Regions around the nucleus. So the regions around the nucleus occupied by electrons. As simple as that. These regions that are around the nucleus, these are our nucleus. Okay? So these regions that are around this nucleus that are occupied by these electrons are called energy levels. So the regions, these ones, around this nucleus that are occupied by these electrons are called energy levels. Energy levels are called energy levels. Okay, so something to note which is very important. I'll practically be able to give an example like carbon. Okay, carbon is number 6. So then it means it has 6 protons, it has 6 electrons, and of course the number of neutrons basically for more stable carbon is 6 also. So we'll come here and say that if this is our atom, at the center, we want to do what? We want to really arrange the electron. Look at this. Electron arrangement, also called electron configuration. What is it? You might get asked in the examination, what is electron arrangement or electron configuration? You'll say arrangement of electrons in the energy levels. I've just said it very clearly. These electrons are found outside the nucleus. And where do they occupy? They occupy energy levels. And I first began by defining energy levels. I've told you energy levels are regions around the nucleus that are occupied by electrons. So these regions around this nucleus that are occupied by these electrons are called energy levels. So these are energy levels. What are they? Regions around the nucleus occupied by electrons. Correct. So electrons occupy energy levels, and energy levels are those regions around this nucleus. And the arrangement of electrons in these energy levels is called electron arrangement or electron configuration. So if someone says, what is electron arrangement or electron configuration? What do you say? The arrangement of electrons in the energy levels. So you want to come here and try and arrange these electrons in these energy levels. So I'll actually come here and say C. You're wondering what is C. When you're trying to show how electrons are arranged in the energy levels, always begin by writing the chemical formula of that element inside that atom. At the center of that atom, in the nucleus, write the chemical formula of the element. So C stands for carbon. So if someone comes here, the person knows obviously this is the structure of a carbon atom. This is the structure of a carbon atom. And of course, we always say that the first energy level will always carry 2 electrons. Look at that. And the second energy level will always carry 8 electrons, depending on the number. But just know that the maximum number that the second energy level can carry is electrons. Whoever desires to do more of this in the university can discuss maybe more crucial concepts like orbitals, quantum shells, you see. But now at your own level, you can be able to limit yourself to energy levels. So the first energy level has 2 electrons, the second energy level has 8 electrons. And of course, the third energy level has also to carry 8 electrons. Correct. So the first level must carry 2, a maximum of 2. The second must carry a maximum of 8. And the third must carry a maximum of 8. The fourth energy level must carry 8 electrons as well, depending on the element, because there's a difference sometimes. So the first must carry 2, the second must carry 8, the third must carry 8, and the fourth must carry 8. Let's begin. This can be my first energy level. So this is going to be the first energy level. The first energy level. How many does it carry? 2. So we shall put 1 here. The first electron. You can use a star or a dot. So you either use a star or a dot to show how the electrons are distributed. It all depends on what the question is saying. So you can use a star or a dot to show the distribution of electrons. So I've decided to use a star. So the first has 2. So we have this first, and this can also be put. So we are equally distributing those electrons. So the first level, this first one has 2. We shall come to the number. It is 6. So we less 2 and see how many are remaining. So how many are remaining? 4. So you can come and distribute this remaining 4 in this second energy level. We can have 2 here, and you can have 2 here. So at the end of the day, we can count. In the first energy level, 1, 2. Then 3, 4, 5, 6. Don't worry. We say the second energy level is 8. But we cannot write here 8 because obviously the electron number is 6. So we can't work with a number which is not there. We have to work with a number which is actually exactly the atomic number of that element, or the number of electrons. So the number of electrons is 6. Of these 6, the first 2 electrons will go to the first energy level. Then out of the 6, we remain with 4. The 4 are distributed in the second energy level. And we can proceed if the number allows us to proceed. And that's the fact we can be able to go in distributing. So this is what we call electron arrangement. The arrangement of electrons in the energy levels of an atom. Electron arrangement or electron configuration. So electron arrangement or electron configuration is the arrangement of electrons in the energy levels. The arrangement of electrons in the energy levels is what you call the electron configuration or the electron arrangement. And you always use what you call the electrons to arrange those numbers in the energy levels. So we can be able to now confirm that we have arranged the electrons in the energy levels, or we've had what you call electron configuration. And we obviously have to ensure that those electrons are in the energy levels. And those energy levels are just the regions around the nucleus. The regions around the nucleus. Begin by first writing the chemical formula of that element at the center of that atom, so that it can be able to give an identity to that atom in terms of knowing which atom has been represented in terms of distributing those electrons. So if you get done with that, you can now be able to talk about something different, and that means you can now decide to maybe use a different example to understand. And if I decide to use another example, let me try to use a different example. Let me use an example of potassium. And potassium is number 19. And of course, the chemical formula of potassium is capital K. I'll draw the structure. I'll be able to first indicate the nucleus and be able to capture the chemical formula of that element, so that this atom is an atom of which element? Potassium. The aim of this is to give the identity to that atom we've actually drawn. So we will begin. We've said the first energy level must have 2. Let me use dots. So you can have the first dot and the second dot. So we shall reduce this by 2. The remaining number is 70. Right. If we go to the second energy level, we need to accommodate this second energy level with how many electrons? 8. So we'll begin 1, 2, 3, 4, 5, 6, correct? Then 7, 8. I'm going to reduce this by 8. Correct. So the remaining number is 9. So we still have more to go. So we are remaining with 9. So 9, we shall go to the third energy level. It must accommodate also 8. So 1, 2, 3, 4, 5, 6, then 7, 8. So we shall reduce this by 8. So what is remaining? We remain with 1. So we shall go to up one more energy level. So it becomes the fourth energy level. So that fourth energy level will remain with 1. So we're going to put here 1. Like that. So let's count. First energy level 2, 1, 2. Then 3, 4, 5, 6, 7, 8, 9, 10. Then 11, 12, 13, 14, 15, 16, 17, 18, then 19. The number of dots or the number of crosses must be equivalent to the number of electrons of the element, or the number of protons, or the position of the element in the periodic table. So if the element is number 19, that means it must have 19 protons and as well 19 electrons. So we are going to distribute those electrons in the energy levels equally. The first level has to have 2, they are here. The second must have 8, they are here. The third must have 8, they are here. You can see them. And the last one will end up having 1. That is what you're supposed to do in terms of what you call the electron arrangement. The electron arrangement. Now, basically, we've been talking about an element getting found in the periodic table. Where is it supposed to be found? How do you end up realizing the position of the element in the periodic table? I'm going to make a sketch of the periodic table and be able to show you how you can be able to indicate the position of an element in the periodic table. So bear with me because the drawings may not be so clear, but I think you are going to understand. Okay. I guess you can understand this. Right, fine, so that is it. And we can have this. let me hope you're going to understand. So 1, 2, 3, 4, 5. Okay, 6. 1, 2, 3, 4, 5, 6, 7. Then you have 8. Correct. So you can have this and this. So you can have this and this. Then you can have this last one and this. Okay. So I'm going first to label this, and then I'll be able to explain to you what this means. Okay. Yes, you understand. These are Roman numbers. So this is what we call a periodic table or a grid that normally houses elements. I've only used from number 1 to 20 because we do not actually need to go up to the 100 or an element coming after the 100. And we will be able to have 1. That's how we actually do the numbering. We shall have 2. We shall have 3. We shall have 4. We shall have 5. We shall have 6. We shall have 7, 8, 9, then 10. We shall have 11, 12, 13, 14, 15, 16, 17, 18, then we'll have 19, then 20. Let's stop there. So this is a grid or a periodic table. It houses elements. This is where elements are arranged, and scientists actually found it so easier for them to identify elements by arranging them in the periodic table. So all the elements were arranged in the periodic table. Elements are just minerals that were actually discovered by different scientists. Those minerals were actually able to get extracted from the ground as very important, crucial elements, and they began getting used. But for their identity and to avoid confusion, they got arranged in the periodic table from number 1 to 100 plus, but we've only used the first 20. So these Roman numbers represent the groups. So elements are put in 8 groups, or they are organized in 8 groups. You can see this part. It has a particular type of elements called transition elements. Transition elements. So forget about the transition elements. We are talking about the elements in group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8. So that is to tell you that all elements are organized in 8 groups. And groups are columns. A column. So these are column. You can get that. So elements are organized into columns or are organized into groups. Are organized into columns or groups. And we use Roman numbers to identify the groups or columns of elements. Now to go across, like number 1, from here up to here, those are periods. So for you to identify an element, you need to know its period and its group. How many columns or groups? 8 groups or 8 columns. How many periods? 1, 2, 3, 4. So you can basically focus on these 4. So how many groups are found in a periodic table that can actually organize elements? 8 groups, and those groups are columns. How many periods can get found in an element? Basically, for this matter, we can use 4. So we have 1, 2, 3, 4. But expect to have even more than 4. So you have 1, 2, 3, 4. So 8 columns or 8 groups and 4 periods. So periods are rows, like this is the second period, second row, the third period, or the third row. So columns are groups and periods are rows. I guess you understand. Transition elements will be an exception. I'll explain to you what transition elements are. But let's focus on those groups which are 8 and those periods which are 4. So assuming I have an element like calcium. everybody knows calcium is an element. I want to see how do I locate this element in the periodic table. It's a very common question that gets tested. So calcium is number 20. For you to know where this element can get found in the periodic table, you need first to actually write down its arrangement of electrons, or its electron arrangement or configuration. How can it look like when its electrons are distributed in an atom or in its atom? So you'll be able to say, we have always been able to say the first energy level must have 2. That is right. So we shall subtract 2 from here. What do we have? We shall remain with 18. The second energy level must have 8. We are using dots to separate those electrons in terms of their arrangement. So we shall subtract 8. Remain with 10. The third energy level must have 8. So we subtract 8 as well. What remain with? 2. So we come and write 2 here. So that the arrangement of this electron will be the first energy level will have 2, the second energy level will have 8, the third energy level will have 8, and the fourth will have 2. So if I say 2 plus 8 plus 8 plus 2, the answer must be 20. 2 plus 8 plus 8 plus 2. The answer must be 20. So 2 plus 8 plus 8 plus 2. It must give us 20. So 2 plus 8, 10, 10 plus 8, 18, 18 plus 2, 20. So 20 becomes now our atomic number, or our number of electrons or protons. We want to locate this element in the periodic table. We've actually come up with its electron arrangement or configuration. We will first know its group and its period to make our work easier. We'll come here. What is its group? Group 2. You're wondering, why is it group 2? You look at the outermost occupied energy level. How many electrons does it have? This outermost occupied energy level has 2 electrons, so that element is found in group 2. Look at the way it is very easy. Sometimes I can ask you, why do you think calcium is found in group 2? You'll say it has 2 electrons in the outermost energy level. Now, next is period. Which period is this element found? It is found in period 4. Why period 4? It has 4 energy levels. The first energy level, the second energy level, the third energy level, the fourth energy level. So the first energy level, the second energy level, the third energy level, the fourth energy level. So 4 energy levels will make it to be found in period 4. 2 electrons in the outermost energy level to make it to be found in group 2. So group 2y, 2 electrons in the outermost energy level. Period 4y, 4 energy levels. Correct. So let's see. Group 2. You can come here, because this group 2, you can put here star on top of that group 2, because it's actually found in group 2. Then period 4. You can come to where there's period 4, you also put a star. Correct. So group 2, then period 4. So you want to see where do they meet actually. So I'll just use, of course you don't need to do this one, you can even use a ruler, but you have to see where they are going to meet. Look at that. So you move across that period, then you move downwards and ask yourself where they meeting. They are meeting in this box. So you're going to put here Ca to mean calcium. This is where calcium is found. Group 2, period 4. Group 2, period 4. Group 2. Then period 4. So that's where calcium is found. That's how you can be able to actually locate an element in the periodic table. It's as easy as that. It's easier for you to actually identify that element in the periodic table because of the way it is very easy for us to understand. Unless you have a question you can be able to ask. If you have any question you can be able to ask. But that's the thing you need to have in as far as the arrangement of elements in the periodic table is concerned.